Okay, so far we have seen about joins. So in join, we saw about natural join, conditional join, and outer joins. So in this one, outer we saw left, right, and full outer join. And after this, we have seen a few examples as well. So now let's do one or two more examples, and then we will move on to our next topic. Okay, let's say I'm having a table that is student with SID and A's, and other is department with department ID, that is TID and DAs, right? So we need to frame the query or say the relational algebra. The question is retrieve SID, right? Retrieve SID whose age is more than age of some department is, that is the age. Understood? So we need to retrieve SIDs. SID is from student table. Remember, whose age is more than age of some department, that is the age. Right? Understood? This is the scenario that we are having. Right? Now, you need to take care of this thing. In the given schema, we have the student and the department entities. But you can see that there is no kind of relation we can see here so far. As I mean to say the relation, the foreign key of any of the primary key of the table in the other key. So probably if DID and SID are the primary keys of department and student table respectively, then none of them is in the other table, right? So in that case, what we have to do, definite, and remember one thing, in such type of scenarios, we need to use conditional join. We have the conditional join plus with some predicate condition. That is your predicate logic, right? How you're joining the tables here. Okay, concentrate on this query now. We need to retrieve SID. So definitely I need the data from both of the tables. So what I will do is I will take the student table, right? And I will do the Cartesian product with department here, right? So what it means? It means what every SID, every row of student is linked with every row of department, right? By we understand this by the cross product we have seen so far. Now in this scenario, we will select those rows only. We are selecting row. I told you selection operation works on row only, right? We will select those rows in which the age of your student, that is your age, let's say I'm writing, whose age is more than, as the scenario says, more than age of some, right? Some DAs, that is this one. Some means there exists any or at least one, we have seen so far in the previous class, right? That means some. So at least one possibility should be there, and that is age should be greater than D age. After selecting these rows, we will project what? SID, that is SID. So this is how we write the relational algebra here. And probably we know this part is called your conditional join, and you can write this as something like this. And condition is greater than what? D is, and project what? SID, this one. So this was well, right? So we have already seen this in the previous class. Now let me take another scenario, right? This was for sum. The key sum was used in the question. Now let's take another scenario where we have a table R with attribute A and some other attribute. Let's say some other attribute. It can be any C, D, E, or whatever. Another table is S with attribute B and some other table. See, this scenario is same as student and the department. There is no common, because if there would be any common attribute, we would have written it here, right? So the question says retrieve A values. Those are more than those are more than every. B value of S. Understand here. So every A value of R should be more than every B value of S, right? So remember, every means for all the mathematical representation that we know, right? So as I told you in the previous class, in a question, when we have the term sum, when we have this term keyword sum, then we use Cartesian product. For example, here we use the Cartesian product due to this. But when we have every, right? If every is used, then what we have to do, we need to complement the situation and then perform the difference operator. This is what we have to do, right? So if I'm saying here is A value is more than, that is more than B, every B value. So what will the complement of this one? Complement will be A values will be less than equal to sum, right? So every is being converted to some B value of S. So A value is less than equal to some B value of S, right? This is what the complement, right? So this is the complement here. And whatever complement we will be receiving here, okay, let's check out on this data set. For example, let's say, okay, now let's say uh, our data is something like this one, R in which A and other S with some B value, that is 10, 20, 30, 40, 15, 25, 30, the previous example, and another attribute values as well, right? So now let's do one thing here. We need to find, okay, what should be the answer. Before that, I need to check a value of R should be more than every B value of S. So is the 10 is more than every B value of S? No. 20 is more than every B value, 20 is more than 15, but it's not more than 20, 25, so no. 30 is more than every B value, 30 is more than 15, 25, but it's not more than, it's equal to. So, okay. Now 40 is, you can see that more than every B value. So our answer should be, our row should be 40 here, right? So what we will do is, we will first try to get these values. And these are what? Whose values are less than equal to some B values. So 10 is less than equal to 15, yeah, but 10 is not less than 25. But some is there, so at least one we have found. 20 is less than 15, no, 20 is less than 25, yeah. So 30 is less than 30. So we will include those in A values is less than some B value, and whatever result we will get, we will subtract these values using difference operator from every value of this A. Right? Understood? From 10, 20, 30, 40, we will subtract 10, 20, 30. We will get 40. That is set difference operator. Yes or no? So to find out this one, what we will do, complement the situation, that is A less than equal to some B of S, right? So we know for this one, for this query, we have already seen. So that is R. So simply I will directly write, I will do the conditional join with S, and what will be the value condition, right? Predicate condition, the A value of R should be less than equal to B value of S. And out of this one, I will simply project what? I need to project what? A values. Why? Because definitely I need a retrieve A values, right? The question says. So I will write R dot A. I will project. So this is what the complement condition. What will the output of this one? 10, 20, and 30. Because these are the values which are less than equal to some B value, some B values of S, right? 10, 20, 30. And now from this scenario, I will subtract my all the A values, that is 10, 20, 30, 40. So what answer I will get after this one? 10 is present here. We need to find those values which are here but not here. So 10 is here, it's here. So okay, no. 20 here, here, same. 30 here, same. But 40 is present here, but it's not present here. So the result is 40. And this is what we expected. Right? So what we will, how we will compare this further? We will write difference operator here, and simply I will fetch R value from the R table, that is A values. So this is the resultant query which will give me the answer here. Right. So remember, for every, whenever we found the every in the every keyword in the query, we have to find the complement and then use the set difference operator. Right. But this every word, we have already seen this every word, where if you remember about division operator. Right. So the syntax for division was something like AB of R and the project B from S. See, there is a difference. Here also we have understood, if we go back to the division operator, right? So what we understood in this one, we need to retrieve A values of R, right? See, understand the scenario. There is a difference. We need to retrieve A values of R. Those are paired with every B value of S. Those are paired with every B value of S. It means what? In this scenario, we have A values, some A values, but also we have B values also. Now there is a link in the single table, that is what R, we have A and B both values. And then on the other hand, in the S, we have B values. So what we are saying is every A value should be linked with all these B values. This is what the division operator says, right? So here in this scenario, the attribute value which we are comparing is present in both the set relation here. But here in this one, if we talk about in this scenario where there is also every, but you can see there is no certain such condition, because there is no common attribute which is present here. So probably if you will try to write this one, if you try to write in the division operator this query, you definitely need to have include some attribute here common, that is of your R, by projecting the B values of S. So you have to write something which is common, that is what it should be B definitely, because we are comparing them with B value, but there is no B value here, right? If there is B value, definitely we have to use this formula, but there is no B values here. And the reason, because of this, we have to use, when there is no this common attribute, we have to use conditional join, that is conditional operator, Cartesian operator with some predicate condition, right? So that's why in this scenario, don't confuse in every. When we have the every in the query, you need to go through the table and see, is there any foreign key present in this one? If foreign key present, go for division blindly. You have to go for division. But if there is no attribute which is common there, you have to perform the conditional join, that is Cartesian, right? So in this way we make use of all the joins here, right? Okay, so with this one we have finished our join part as well, right? So now let's move on to the another important operator, that is called the rename operator, that is rename, and we used to represent by row, right? So as the name says, what is the use of this operator? We use this operator to rename what, either your table, or you can say your attribute as well. We can rename both table and attribute. So why there is a need of this rename operator, right? So we will see that. But before that, let's look at the things how we can use this rename operator. For example, now let's say I have a student table with SID, certain attributes as SID, as name, and probably let's say age of the student information. So now what are different ways with the help of which we can use this operator? Understand, if I'm writing this one, let's say I want to rename my table, right? As I told you, we can rename table as well as attributes. When I want to rename my table, my syntax will be use row, the first name that you actually want to give to the table, comma, the previous name of the table. This is how. So if we use this one, it means what? My table is T now, and I have the same attribute. The name of attribute is same, but the name of table is changed from SID to T. Now probably if I want to extract any of the attribute of this one, I have to use T.SID, T.SName like this, T.is. Right? First is the name of the table. The other way is row student, something like this one, and I rename the attribute. Let's say I and is something like A. So what it means? It means that my table name is student, same, but I have changed the name of attribute. Remember, the sequence should be same as the domain should be same as the domain in the actual table we have. That is first for ID, second N is for name, and A is for is. So how you can access this attribute from the table? That is student, which is the table name dot I, student dot N, and we say student dot A as it is. This is how we used to extract the attribute from the table. And also it's not like compulsory that if you rename the attribute, every attribute should be renamed. No, that's not. You can rename attribute as per your requirement. For example, if I want to rename only this attribute, that is student, something like this, I want to rename SID to I and A's to A. This is, see, if I want to rename a subset of attributes, not the all attribute. So I will use the previous name of attribute, arrow sign, and provide on the right side the new name. It means what? I still have the student table as STUD name, but my first attribute will change to I. The second was name. So there is no name change here, attribute name change. So it will remain same as S name, and age is changed to A. So this is how. Right, so again, if you want to access the attribute student.I, student.sname, student.a, in this way we use the rename operator here. Right, so always remember, there is an important point here. Always remember self cross product of relation R. For example, if I have R relation, the self cross product will be what? R cross R. Right, so this is called your self cross product. So self cross product always require to compare, always required to compare what? One record of R. So what basically it means? You are comparing one record of R with some other record of R only. Yes or no? So for in the R record, in the R table, you are taking one record and you are comparing that record with some other record of itself. That is your R here. Right, in this case we need to use rename operator here. Right, so that's why, okay, why we use, because we have two tables here, that is R and R. Right, we have, let's say, student and student, which, let's say we have attribute A comma B comma C here, then definitely we'll be having A comma B comma C here as well. So with A, we will comparing this A with B with every say the row of this table. So single with everyone. So this is what the Cartesian product is all about that we have seen so far, right? But now understand, when we will comparing this one, the single record of this table with every other record of this table, probably the compiler will be confused, like what records we are doing compare here. To avoid this type of confusion with the compiler, we generally used to use the rename operator here, right? So this scenario will be much better and efficient if you use something like this one. You want to do Cartesian product, okay, that's fine. You rename this T, R by T, and then probably you can do anything that you want to. Right, now ABC will be here, right? But here ABC will be the same, but when you will access the attribute, it will be T dot A, T dot B, and T dot C. Here R dot A here also, R dot A here also. But here R dot A with T dot A. So this is what different, right? So in this way, we use the rename operator, right? So, okay, understand, if you haven't understood this one, so if you find any difficulty, You can just go back and again replay this part video and try to understand, because now we will solve a few questions which are generally kind of famous and used to ask in most of the exams, right? Especially on the rename operator. Okay. Okay, so now let us understand this rename operator with the help of example. Okay, that's fine. So our table is student and we are having SID and age as the attribute here, right? This is my single table, that is student, SID and essays, sorry, age, right? So the question is, we need to retrieve SIDs whose age, yeah, right? So whose age is than now first take the condition of some, then we'll go for every, whose age is more than some student is. Understood? So in this table we are having the information of the student, where the student ID and the student age is stored. So different student may have same as well as different ages. We need to find out the SIDs of those students whose age is more than some student age. So some here means there exists any or possibly at least one, the same meaning, at least one, right? So we need to find out at least one row should be there whose age, student's age is more than other students' age. This is what our scenario is. For example, let's understand with the help of tabular format by taking certain values here. For example, SIDs are S1, S2, S3, and S4. Age we can say 20, 18, some random values 22 followed by 21, like this. Now, if I have taken these values here, possibly it should be same here as well, right? Because this is the student table. Again, there is student table. See, whenever understand, this is a self-recursive relation, right? Self-referential relation we have seen in this ER diagram as well. Because in the single table, we are comparing one row with other rows. So remember, for comparison, I just use the word comparison. So comparison always exists between two or more, right? But we have one table, definitely we need to take the same table, right? And then we need to perform the comparison, every record of one table with every other record of same table, right? So again, we need same table but two times, that is S1, S2, S3, and S4. Definitely values remain same. Okay, it's 22, definitely it's 21, it should be same. So now remember, okay, what we have to do now, retrieve SID whose age is more than some. Okay, now take this student S1 here, and now let's check it out with this single row. Compare every row of this table, other one, right? If this age is more than some age, then definitely we will take this one. Okay, 20 is more than 20. Oops, no. 20 is more than 18. Yes. So definitely we will take. Probably there might be chances of this 20 can be more than some other as well, but at least one should be there. If this condition scenario satisfy, we're gonna include this one here, right? Again, check as to 18 is more than 20. No. 18 is more than 20. 18. No. 18 is more than, no, no. So we can take this. 22 is more than 20. Yes, take. 21 is more than 20. Definitely take, right? So the answer should be, for this one, for this query, our answer should be S1, S3, and S4. Yes or no? Right? So see, this is what approach I have followed. See, now how to write the relational algebra here, right? So see, what I did is I took the every record of this one and compare with every other record. What this logic operator says, how with which operator we can do that? Obviously, it's a Cartesian product, right? So there should be a Cartesian product between these two, right? But definitely understand. Okay, let me write first student, and we should have a Cartesian product with student only. But definitely we will use a rename operator here. So now let's say I'm using rename operator and I'm renaming the table name for instance now by T, right? So what it means, after this one, once I have done this one cross product, I will select those rows. See, after this one, after doing this one, what I have actually done is I have written virtually, I have written a table, right, by the Cartesian product, in which every record of this one is related with every record of the same one, every other record of the same table. That is one, right? Now I will select all those records in which student dot age is more than T dot age. Yes or no? Because we have one table that student attribute and is as T dot age in this one here. So once we have selected those rows, possibly we will reflect corresponding SIDs now. But SIDs are here also and here also. Which SIDs? Definitely in this first one, that is what student dot SID. This is the way how we write here. So if you remember, this part is called your conditional join, right? And how we can rewrite this query: student T dot student here, stud fine, and write the condition. What's the condition? Student dot age is greater than T dot age, and we simply reflect what student dot SID. This is how we write. So in this one, what we have done, we use the rename operator, but on table name. Okay, now can we write the same relational algebra query by renaming the attribute name rather than the table name? Okay, let's try it out. Again, I will use directly conditional join here. Remember, instead of every time writing the cross product and selecting this scenario here, I will definitely prefer to write the conditional join, right? It means same. So possibly, as I just told you in the previous class, you should have this thing in mind whenever I will write this one as this. So you should possibly this should come in your mind what actually have happened when I have written this one using what your conditional join, right? Okay, move on to this one. If we want to rewrite this using renaming the attribute name right now, so this is what we have renamed the table. So what I will do is simply, okay, let's take the student, fine. Now we need to rename what attribute names. So definitely we will write, I will write the rename operator followed by student table. But now in this, the lower of this one, we need to write how you are renaming the operator. For example, I want to rename I, that is student ID, and A is by A. This is one. This is what I have written. So now since this is conditional join, I need to write this condition as well. So what my condition will be here now, student here, the age of the student, this in this table we have the student attribute, that is age here. Student dot age should be greater than. Now here in this table my age is defined by the attribute capital A, so I will write capital A here. Even you can write student dot A, but it means same, right? Possibly you can write age is greater than A as well, so there is no difference. So once we have done this one, I will project student dot what, SID or simply SID, both same thing you can write, right? Because we have the same different tables, same table but different attributes here, right? So this is how we solve the question, right? So I hope you have understood, but definitely to make this thing more clear, let's do a few more interesting example. We have seen for some, let's see for every as well. But before that, can we write the query for this situation where we have employee table followed by EID as employee ID, SAL as a salary, and department number, the employee is working in certain department number, followed by the attribute D number. What I'm asking is you need to retrieve EIDs whose salary is less than, again I'm using some, less than some employee of department. Let's say I'm specific to now department, that is department equals to 5 here. Just fine, we can do that. right? So understand here what we need to retrieve EIDs of those employee whose salary is less than some employee. There is some employee, right, who is working in department 5 is having less salary, right, more salary, right? For example, we are talking from this side, more salary than some other employee here, right? So whose salary is less, we need to reflect those that particular employee's EID. Understood, right? So understand, see how I will do here. Just forgot this one if it seems to be new right now. First understand that we need to retrieve for department only, some department. What is the department? Okay, we're gonna handle this later on. Retrieve the EIDs of employees whose salary is less than some employee. We have seen this, right? How? Take the employee, let's say I am using the rename operator, right, of employee E as an EMP. This is what. So what this means so far, if I'm writing employee and this is what, say the conditional join, what's the condition? The condition is the salary of this employee should be less than some other employee salary. So in this employee, my salary, how I will access? EMP is my table name dot attribute is what? Salary. This should be less than E is my this one, E dot sell. So when I write this one, this scenario, right, what it means, I have retrieved those tuples here in which employee's salary is less than some other employee's salary, right? But now after writing this one, it's not completely finished done, because we need to retrieve only those EIDs of employees who are working in department 5. So since in this scenario, we are now selecting only those rows in which E dot department equals to 5 here. See, I haven't written EMP dot department. Why? You need to think of, just analyze. We are retrieving the EIDs of employees whose salary is, see, these are two conditions. We have constraint. See, the predicate logic is on, or say the condition is on salary should be less than plus department should be 5. So in this table, we need to look at the salary. Salary should be there, this condition, and as well as the employee whose salary is less than should be in department 5 as well, right? So that's why we will put this condition, selection condition on this one, E dot department equal to 5. So once we have selected rows, we will simply project what? EIDs, that is EMP dot EID, right? So this is how we write the query. Okay, see, this complete scenario, this one, I can write in a once, and that's what, how, see, EMP row E comma EMP, that's fine. And see here, what are the predicate conditions here? EMP dot cell should be less than E dot cell, and see, and operator, this cap, right, and E dot department equals to 5. We can write both of this. There can be multiple predicate conditions, and I will simply reflect what EID here, or you can say EMP.EID, anything same. So this is how we write the scenario for sum, that is their existence, right? Okay, go to the every part now. Let's see. My query is need to retrieve. We need to retrieve EIDs whose salary less than, whose salary is less than every employee of department 5 here. Okay, you can see, right? So we need to retrieve EIDs whose salary is less than every employee. Should be every, right? Every employee of department 5, right? So now what we have to do, as I just told you, in every part we need to First, find the complement of this one, right? What will be the complement of this one? Should be less than every. If less than every means greater than equal to some. Greater than equal to some employee of what? Department 5. This is what complement condition. And out of this one, we will subtract EIDs of all employee. Possibly we will get every condition here, every employees, right? So this we already know, yes or no? We have already seen for some employees greater than salaries greater than equal to, and that's what EMP. In the EMP, simply I will do conditional join by, okay, let's say this time renaming the attribute here, that is salary, whose salary is greater than equal to, salary is greater than equal to, renaming this one with ISD, ID, salary, and D, what's that? Department number. So salary of this one should be greater than salary of this one, S. Yes or no? Fine. And department number 5, that is D, capital D equals to 5. So this is what, out of this one, I will simply project what? EIDs. So this is what condition for greater than equal to, the complement part. And out of this one, I will subtract the EIDs of all the employees. So I will simply project what? EIDs of what? EMP, that is this one. So this is what the condition for my every, that is for all. Understood. So in this way, there is nothing so difficulties here, right? This is what basic we are already doing from this one, and then finding the complement condition for every part here, right? Let me make some more interesting. If you can just try by your own, just let me know if you face any difficulty. In the same part, if I'm giving you the scenario like EMP, you will find this very interesting when you will just try practicing by your. There is a table EMP with EID, gender, and salary. This is the scenario. I'm asking you, you need to retrieve EIDs of female, see, of female employees whose salary is more than, okay, whose salary is, what we can say, whose salary is more than some, take some male employee. Yes or no? So we need to retrieve female employees. Out of this one, we need to retrieve female employees whose salary is more than some male employee, right? So on the second table, you need to retrieve first male employees, or we can say male employees, and also whose salary is more than, female employees' salary is more than those male employees, right? So you need to retrieve those and simply subtract it from all the female employees of this one here, right? So let me know if you face, okay, you are not required to subtract because we are working on what uh, some part here, right? Definitely you're not required to subtract, right? So simply you will find out salary greater than some male employee. First, salary is greater than us, and simply gender should be male, right? So within a single go, you can write this one, and possibly you can try for the same. Instead of some, you try for every as well, right? The all the part remains same, but the sum will change to every, right? This is how you need to understand, and possibly you can try. Let me know if you face any issue. You should be easily able to do that. Okay. So in the question, see, I have written every word. For example, we have seen some example in which word every was used. But remember, there is an alternate for every as well. For example, what I mean by this one is, let's say I'm having EMP is a table where EID and salary is there. So what sometimes the question used to say is, you need to retrieve, don't get confused, you need to retrieve EIDs whose, okay, who get the employees, or sorry, EIDs who get highest salary. That is what the maximum salary. Yes or no? Right. So we need to retrieve the employees EID who get highest salary. What should be the logic now? Remember, highest salary, what it means? If we think of highest salary means employee with EID, those employees whose salary is greater than equal to every employee's salary. Yes or no? This is what we mean to say by the highest salary. Yes. Y equals to, definitely we can have more than one employee with highest salary, right? So employee's ID whose salary is greater than equal to every employee's salary is possibly your highest salary, right? This is what we need to retrieve. So again, we have greater than equal to with every, that is for all. So what should be the solution for this one? First, go for the complement part. So the complement of this one will be what? Greater than equal to every means less than some. Yes or no? Less than some, and you subtract this from all employees EIDs, employees of EID, and you will get the answer for this one. Yes or no? So highest salary is basically means the salary greater than equals to every employee's salary, right? So indirectly some questions can be can be given to you. Okay, so there are other lot of questions as well here in rename operator, but by time we will try to solve those questions as well. Okay, so with this one we can say almost finished our rename operator by this one. So just let me know if you face any issue in this one, the name operator that we have done so far right now, followed by the example. The examples are very important here, right? So you need to have grip on writing these square. This is a relational algebra. And remember, these relational algebra are not so hard. There are things which will be more complex, or say more logical, kind of more mathematical, when we'll move on to TRC, DRC, and correlated nested queries and all. So, but for those, these are the must. These are kind of you should have a strong grip over them, right? So try practicing those questions as many as you can, and just let me know if you face any issue. Okay. So in the next one, possibly we will try to solve more questions on this one. There are certain more specific questions as well here, right, that we need to solve. I also go through those questions. So in the next video, or possibly in the next lecture, we will cover those topics. Yeah, okay.